All right, today we have a simple problem on parallelogram law vectors that we need to solve. So there's a question here on the chalkboard that we need to start solving. Using the diagram below, find the resultant force controlling the two forces and the direction of the resultant force. Here is the diagram. We have a force that is going to the A direction, and we have another force that is moving to the B direction. We have these two forces starting from the origin. So we have the 3 Newton force and the 2 Newton force being overlapped at an angle of 25 degrees. So we are asked to look for the resultant force and as well as looking for the direction of the resultant force. So here we will sketch this diagram so that we'll be able to find solution to this. So this is how we do it. So we start from here. We have it this way. We reproduce this line at the top with dots. This is vector 1 and this is vector 2. We can move this one and reproduce it this way too. So we have a resultant, a diagonal line from the center. Remember the original angle between A and B is 25 degrees. Now we represent the direction of the resultant vector with the symbol alpha from this little opening alone. So for us to be able to get the angle that is formed at this point, all we need to do is to subtract this angle that is here is a corresponding angle with this. So here we have 25 degrees. This 25 degrees is corresponding with this side that we are having. So here we have 180 degrees minus 25 degrees at this point. That is sum of angle on a straight line gives us this one. So we will now come up. What we have done in this place is this. Call this one T, call this one P. So here we have angle AOB is equal to angle PBT. Angle PBT, which is equal to 25 degrees. Corresponding angles. This particular segment, O BP plus P BT is equal to 180 degrees. That is sum of angles in a straight line. In a straight line. So we have this box. Originally, I have to clean this for you to understand what I'm doing. Here, originally, we can denote it with, let's just keep it the way it is, so that we find OBP plus PBT, which is this angle, 25 degrees, and equate it to 180 degrees. So here, we have OBP to be equal to 180 degrees minus 25 degrees. And the answer we have in this point is 180 minus 25 is giving us 155 degrees. So this spot, we are having it to be what? 155 degrees. So we will sketch this diagram and then we have this only. We have this only. So we have O we have P, and we have B. So here I'm free to have 155 degrees, and here I have the direction of the resultant force. So here is my resultant. So with this, we can find the resultant of this. Now, to get the resultant of these two forces, here I have 3 Newton, here I have 2 Newton. To get the resultant of these two forces, here I have 2 Newton, here I have 3 Newton. Using Cosine rule, that is, OP squared is equal to OB squared plus OB plus BP minus 2 multiplied by OB and then BP multiplied by cos 155 degrees, or we put it as cos 180 minus theta. This becomes the formula that we are using as a cosine rule. So we will now substitute the values into it, where this one becomes your r squared. This one, we have it to be 2 squared plus here we have 3 squared minus 2 multiplied by 2, 3 cos of what? 155 degrees. So here we have r squared to be equal to 4 plus 3 squared is 9. Then we have 2 multiplied by 2 multiplied by 3. Here we have this one to be 6. Then we have our cos 155 degrees. Here we continue with the evaluation. 4 plus 9 gives us 13. Here we have 13 minus, we now multiply, or we find the value of the cos of 155. Cos 155 is giving us, here we have minus 2 times 6 is giving us minus 12 multiplied by minus 0.9063. So here we have r squared to be equal to 13. Minus multiplied by minus gives us plus. Then we multiply the results. What we have there, we multiply 12 by 0.906. 12 times 0.9063. We are having it to be 10.8756. R squared is equal to, we add the result with 13. We have 23.8756. Now we take the square root of this so that we'll be able to have the resultant. So here we have r to be equal to the square root of 23.8756. So r is equal to, we take the square roots and then we have 23.8756 to be equal to 4.89 Newton. We can decide to approximate it and have it to be equal to 5 Newton approximately. So this becomes the resultant of the forces that is controlling the two forces from this diagram. The next thing is to find the direction. So for us to get the direction of the resultant force, to get the direction alpha, of the resultant force, we use sine rule. That is sine, we use the sine of this angle, we call it sine 180 minus theta all over the side that is facing it, which is r. We equate it with this side. We have it as sine alpha all over this direction, BP. Alright, so we will now substitute into this, which implies that this is sine 155 degrees all over the value of the resultant that we've gotten here. We'll now insert it 4.89, which is equal to the sine of the direction. So here we have sine alpha, which is what we are looking for. The BP is this sine, so we replace it with value 3 Newton. So if we cross multiply from here, we will have sine alpha to be equal to 3 multiplied by sine 155 degrees, this multiplied by this, and then we are dividing the whole thing by 4.89. So from here, we move on. From here, we move on, and then we get to the final of the problem that we are solving. So here we have sine alpha to be equal to sine 155 is giving us 3 multiplied by 0.4226. We divide it by 4.89, which is equal to 3 multiplied by 0.4226. We have 1.2678 divided by 4.89. So this is equal to 1.2678 divided by 4.89. What we have? We have 0.2593. Now, for us to be able to have this alpha standing alone, we take the inverse of this alpha. Taking the sine inverse of alpha. So we have alpha to be equal to sine inverse of 0.2593. So here we have alpha to be equal to 0.2593, and the answer is 15.029 degrees. Therefore, direction of the resultant force alpha is equal to 15.03 degrees. That becomes the final answer of the problem that we